Good afternoon, and thank you for joining us for another edition of Build Your AutoCAD IQ. My name is Victoria Studley. I'll be your moderator today. I'm joined by my colleague Alex Buller, who will be presenting the majority of the content here. And we're also joined by our expert elite, Naman Misorwala. You might recognize Naman from the forums. He's one of our expert elites there. All right, so today we'll be presenting solid editing tips and tricks in AutoCAD 2017 as part of our Third Dimension series. Alex will be walking us through some of the different editing tools that will help you model using some of the basic things that we've learned along this series throughout the year. So again, I'm Victoria. I'm based out of our Manchester, New Hampshire office. I support AutoCAD and AutoCAD architecture. Alex is based out of our Boston, Massachusetts office and supports AutoCAD and Map3D. And Naman is based in Westchester, Ohio, as part of our expert elite community. This will be our last presentation of the year, so thank you for joining us. If you've been with us all year or if you just joined us today, we're happy to have you either way. We'll see you again in 2017. About mid-January, we'll see some AutoCAD for Mac 2017 new features. And in February, we'll pick up the series again with some new content and maybe a slightly new format. The links here will bring you to our AutoCAD webinar playlist on YouTube and the data sets in our Box account. And again, on the right here, you've got links to our community forum, the page to send your friends to register or sign up, and the AutoCAD Customer Council aliases where you can join the beta if you're interested in that. So before we get started, I'll leave the agenda up here on the slide. These are some of the basic things that we'll be covering. We may not get to all of them. We might throw in some things that aren't up here. We'll leave that up to Alex to decide. Without further ado, let me turn it over to you, Alex.
All right. Thank you, Victoria, for that great introduction. All right, let's get into it. And before we really go any further, full disclosure for you guys, I'm not a designer, I'm not an architect, I'm not an engineer. So when you're looking at this screen right now and you're kind of looking at our bike design, you might be thinking, what is going on? But we thought it would be pretty cool to come up with, this cool design for a bicycle where we're incorporating the Autodesk A as our frame and the AutoCAD 2017 product logo that you see in the upper left corner as the wheel rims. And I got help from my daughter coming up with this design, so I can't take full credit. But so yeah, here we go. Like Victoria said, we've actually done this webinar before, the tips and tricks. And instead of just rehashing the same thing over again, we thought we would do a case study. And in this case, let's design a bike. Like all of our starting points, we're going to start off with some very basic designs, both in plan view and in profile, as well as some other elements. And from here, we can go and we can start creating things in 3D. So let's get started with the wheel and rim assembly. Now, if you guys are following along, I just want to point out that I'm primarily going to be in the 3D modeling workspace. And also the other thing is I'm going to be in the X-ray visual style. And it kind of helps visualize what's actually going on with some of these 3D solids. I'm also going to be rapid firing through a bunch of different functionality, things that were covered in other webinars, and we'll also have links to those webinars at the end of our PowerPoint presentation, and you guys will have access to that as well. So first off, all I did was I copied over the tire and the design for my rim from that previous file. And the first thing I'm going to do is I'm going to create a torus. And I actually have these dimensions. You would get, your dimensions and sizes from your your model that you created. I'm not going to go over that in detail right now, but essentially I'm going to start off by creating a torus. I'm going to grab this guy, copy it over here. All right. Now the next thing I'm going to do is I'm actually going to create a sphere. And the reason I'm creating a sphere is because I want to start getting a general sense of my rim and the geometry of my rim. So if I actually go back to my 2D design, if I look at the plan view, you'll see if I'm looking at it from the top, I actually have my rim protruding out from the center of my tire. So if I click on this, you'll see that it actually has a radius, some god-awful number that I'm never going to remember. So I'm actually just going to grab that. I'm going to do a Control-C, and I'm going to go back into my wheel environment, and I'm going to create a sphere centered about that torus. Whoa, I'm in the wrong layer. Let's make sure we're organized. I'm going to create a sphere in the center of my torus with a radius of that same diameter that I saw before. So I'm just going to do a Control-V in the command line, and then there you go. I'm going to actually move that over a little bit more. Now if I look at this from the front, it's really not that useful to me. It's completely encompassing my tire. What I'm going to do is I'm going to move it up along the Z-axis, and I can move it up by the radius, but I want it to be protruding down below my torus by some measurement. And if I go back to my 2D design, I actually know what that is. You'll see that I have 36 millimeters. Oh, by the way, everything I'm going to be doing is in terms of millimeters today. So this is going to be sticking out 36 millimeters from the center of my tire. So what I can do is select my sphere, and on my Z position, I'm going to select the calculator. I'm going to do a Control-V. That number is still on my clipboard. Minus 36. Hit apply, and then there you go. So this whole sphere is shifted up. And you can see if I zoom in, now I kind of get that correct geometry between my tire and the edge of my rim. I'm going to copy this guy over. But this is kind of useless to me right now as it is as well. I don't want the entire sphere. What I'm going to do is I'm going to slice off the top bit of this thing here. So if I go to the Home tab, you'll see this little slice guy. It's the slice command. I'm going to select that. I'm going to select my sphere, hit enter, and I want to slice this along the XY plane at Z equals 0. So I'm just going to type in XY, and that's because I designed everything on that XY plane at Z equals 0. So hit enter, and it's going to ask me what side do I want to keep, so I'm just going to click somewhere down below, and then there you go. Sliced away the whole top of it, and all I'm left with is the bottom edge. That is the geometry that I designed again in that plan view. I'm going to copy this over, but I only have half of it. I really want the other side too. I'm going to turn off my wheel. So you can see I really only have the bottom half. I'm going to use the 3D mirror command. And I'm going to mirror this about the XY plane at Z equals 0. I don't want to delete my source object. And there you go. Now I got both sides of it. Right now, it is two separate 3D solids. And that can be kind of annoying down the road for design work. So what I'm going to do is I'm going to merge them. I'm going to use the union command, this little icon up here. I'm going to select my two halves, hit enter, and then there you go. Now I got one 3D solid representing the entire rim rather than two halves. We're getting closer. I'm going to turn my wheel back on, and the wheel is essentially representing the rubber part that actually touches the road. You take a look, and you'll notice that my rim is actually protruding into my tire, and I don't want that to happen. That's not very realistic. what I'm first going to do is I'm actually going to copy my torus, or my tire. I'm going to place it exactly where it was before. So it's right on top of each other. If I have my selection cycling on, if I click on it, you'll see there's actually two of them right there. And the reason for that is I want to subtract one torus away from the rim. If I go back up here, this icon right here is the subtract command. I'm going to click on that. I'm going to first click on what I want to keep, hit enter, and then I'm going to click on one of the toruses, or my tires, and hit enter. And so if I shut off the wheel, you'll see what happened. I took my rim and I subtracted, whoa, hey, crazy screen. I subtracted the tire away from that, so it has this nice curved edge to it, much more representative of an actual rim. And if I zoom in, you can kind of see how the torus is now coupled directly to the rim. So now let's start working on the actual design. I'm going to go over here. I'm going to grab my AutoCAD 2017 design, and actually, you know what I'm going to do is I'm going to actually place this on a temporary layer here. I'm going to grab this guy and I'm going to center it directly over my rim. But if I orbit three-dimensionally, yeah, it's kind of like buried in there somewhere. So what I'm going to do is I'm going to shut off these guys. I'm going to grab this guy and I'm going to just shift it down along the Z-axis. I'm going to turn my rim back on. And the reason I'm doing that is I'm going to extrude the components of my design up through my rim. I'm going to grab each one of these. And I want to make sure they perforate the rim. Whoa, all right, that was extreme. All right, I'm going to use the subtract command again, this guy up here. And again, first thing I want to do is I want to select the thing I want to keep, hit enter. Then from here, I can grab all of those extruded 3D solids and remove them. And turn the wheel back on. And look at that. Very quickly, we got our design for our tire and rim assembly. So what you could do is later on is you can just bring this into another file, a master file, and just essentially duplicate this. So there you go. That's our wheel. Next, let us go to the gear and crank. This one's pretty cool. I'm going to start off, again, all I did is I went to my, profile view and I just copied and pasted my design over. And everything was designed to scale. So I just grabbed that and I grabbed my outer circle for the gear along with one tooth. Oops. And the first thing I'm going to do is I'm going to extrude the circle up, let's go 5 millimeters. I'm going to take that one gear tooth and I'm going to do the same thing. I'm going to go up 5 millimeters. So you can see how the tooth and outer circle are coupled. But this is not really representative of an actual gear tooth if you've ever taken a look at one. They have these tapered sides on either end. Not to the degree of the front and back, but they do taper. And what I could use is if I go to Solid tab, see this taper face? I'm going to select that, and holding down the Control button, I'm going to select this face, hit enter. And then I'll be prompted to specify the alignment of how I want to taper this. So I'll select the back end and the front end, and then I'm going to be prompted to enter an angle. I'm not going to do anything too severe, so I'm going to do 5 degrees. I'm just going to quickly enter out of that command to show you what just happened. So now instead of a flat top, it's now tapered. And I could do this for the bottom as well, again, to get something more representative of an actual gear tooth. Five degrees as well to make it symmetric. And there you go. We have a pretty cool tooth. But I only got one of them. I'm going to need to kind of move this all around, and I can do that by doing the 3D array command. 3D array, select the object. There you go. And enter the type of array. It's going to be a polar array because it's going to be going around the z-axis, so P for polar. Enter the number of items in the array. I know from my design way over here I had 50 of them, so I'm just going to type in 50. Yes, I do want it to go all the way around the circle, 360 degrees. And do I want to rotate the objects? Yes, I do want to rotate along. And then select the center point, and then the axis of rotation. So I'm going to go up along the Z, and then there you go. Starting to look a lot more like a gear, isn't it? Very cool. I'm also going to want to get rid of that whole inside part. So I'm going to get the inner circle. I'm going to grab this guy. I'm going to bring it over. Going to be careful with where I place it. And I'm going to go underneath. Go back to my Home tab, and I'm just going to extrude the circle up through there. And we're going to use the subtract command again. There you go. It's really starting to look like our design here. So we're about halfway there really in terms of this assembly. Next, we want to work on the actual crank. So I just took the one design that I had, and I'm going to extrude it up. I'm going to go 5 millimeters. And what I'm going to do next is I'm actually going to duplicate the whole 3D solid. I'm going to bring it up right on top. So essentially I have 2 layers. And if I put this on my bike right now, I'm going to be presented with some very, very sharp edges. And if I'm pedaling along, you know, probably not the best idea. It just seems like a hazard waiting to happen. What I can do is if I go back to the solid guy here, see this fillet command? Well, a fillet edge. I'm going to select that, and I'm going to grab the top edge of this thing. And down here I have a couple of options, chain, loop, and radius. I'm only going to be worried about the radius right now. It's going to define the curvature of that new edge of that 3D solid. So I'm going to put something pretty aggressive here, 50 millimeters, enter out, and then there you go. I'm starting to get a nice, more curved edge, and probably something more realistic to what we see on bicycles. I'm going to do that for all of the other edges around the side. I'm going to keep entering out. I'll remember the parameters that I put in. Do this pretty quick. One more to go. Oh, where'd that go? There it is. 50 degrees. And just so you know, if you guys are like rotating around and something like that happens and you kind of get lost, you can always go back to like the home. I find it super handy. All right, so I've now smoothed out the edges of my crank, but I got some pieces that really I don't want to be including in my design, specifically around the bottom here. And I'll show you why. If I grab this guy. And oh, actually, while I'm thinking of it, a tip and trick, when I ran that 3D array command on these 3D solids, it's actually going to treat each and every one of these as a separate object. So it's really important that you have the design you like before you run the 3D array command. If not, you're going to be modifying every single one of these. But once I've done that, I'm actually going to quickly union these guys to make it one solid thing. And what I was saying before, if I copy this guy over to my crank, you'll see that some components of the crank are actually going right through it. And this is the primary motivation between duplicating that original design on top of it, because I want one component to be along the inside edge of my gear, and also I want another component to kind of go along the outside edge of it as well. But I don't really want my crank going right through my gears. That would not work. I'm going to go and I'm going to subtract that gear out. And I have now created this gap in the bottom layer of my assembly here. But I can't really just delete that one part that I don't want without first separating this component. Over here we have the separate command, or sorry, solid edit, it's the separate. If I click on that and I click that bottom guy and just exit out, I've now separated this into two separate 3D solids. So now I can go in, bam, delete that section that I don't want. I got a couple circles underneath that I'm probably going to want to cut through. Whoops. So I'm going to extrude these guys up through the design. Just like that. And so I don't have to keep doing this routine over and over again in this section, because I have two separate 3D solids that have the cylinder protruding through it. I'm actually going to union these guys first, so I only do it once. There we go. So now it's one piece. But had I done that before, I wouldn't have been able to easily remove that lower section over here. But now, quickly get rid of these guys. Starting to look pretty cool. Going to copy this guy over. And look at that. It looks pretty solid. Well, it actually looks like a bicycle crank and gear. So there you go. Let's move on. So we've tackled the wheel. We've tackled this gear and crank assembly. Let's move on to the frame. So just like the other two components we made, we're going to start off by just copying over the plan and profile of the frame. I'm going to go into my isometric guy. I got this measurement here because this is going to tell me how high I'm going to want to extrude the frame. I'm going to start not by making a sphere, but actually extruding. Make sure I click the right thing. I'm going to grab my plan view, and I'm going to go up that 809 millimeters. All right. I'm going to copy these guys over. And I have a sneaky impression I just dropped it down on the Z, so I'm going to do that over again. Copy. There we go. I'm going to take this plan view, and using the 3D rotate command, I'm going to rotate it about the x-axis so that it's now on the XZ plane. First thing I want to do though is I'm going to make sure I select the very bottom of my design, because I want this line to stay on that Z equals 0 plane. I'm going to grab this one circle representing the x-axis, the rotation axis, and I'm going to rotate it by 90 degrees. So now if I look at it in front view, you can kind of see that they're overlapping each other pretty cleanly. Had I not done the 3D rotate on that bottom axis, it would have been shifted down. It would have been occurring somewhere down here. So again, that was something that I really wanted to do, and it's just to stay organized really with our design. I'm going to copy this over. And again, I'm going to extrude these two design elements through my frame. This go round, what I really want to do is I want to identify where it is that this 3D solid intersects this outer design element. So to do that, I'm going to use intersect. I'm going to select the two 3D. I think Victoria just brought something to my attention. You're right. For clarity, sorry, I realized I was not in the X-ray. So let me go back. So make it clear for you guys. Maybe, maybe not. But again, I want to find out where these two 3D solids intersect. So again, I'm going to go over here to intersect. I'm going to select those two 3D solids, enter, and then there you go. So I've now created a new 3D solid of only those locations where there was an actual intersection occurring. Want to keep going? I'm going to use the subtract this time because I want to poke a hole through the middle. So there you go. Starting to look something like a frame. But I realized there's one little bit that I forgot to do. I just want to poke the holes through the frame for where the tire and rim assembly is going to go. So I'm going to go back to my original design. I'm going to grab these circles. I'm going to right click, clipboard with a base point. I'm just going to grab something identifiable over in this corner. I'm also going to pay attention to this measurement here. So from the bottom up, I'm going 175 millimeters. So if I go back to my frame, I'm going to right-click, clipboard, paste as block. I'm just going to grab that same point of origin. And if I circle around here, you see I got my two circles. But they're on the wrong plane. My design's up on the kind of this orientation, but these guys are oriented 90 degrees off. But that's not a problem. They are blocks, so I'm actually going to select them and explode them to break them down to their two circles. I'm going to use 3D poly to create a 3D poly line. I'm going to go up 175 millimeters, and I'm going to cut through. Doesn't matter how far I go. I'm going to copy this guy over. So now I got my two guys, and I'm going to use the sweep command to take these and sweep through my frame. So now I could then use the subtract again, select my frame, select these two guys, and then bam, there we go. I now have the start of a frame modeled in 3D. All right, we're going to take a step away from the frame for now. Want to keep working on these individual elements. Next will be the handlebar. So I'm going to start over here. And this one's a little tricky. Maybe not as tricky as a saddle, and I kind of saved the saddle for last. But this one here, I want to start thinking about how I can do this in 3D. The first thing I'm going to do is I'm going to actually create another 3D polyline. I'm going to start somewhere over here. I'm going to go along, creating points along the XY plane. I'm going to get to this point here, and then I got to start thinking that I need to go downwards. Negative Z, 127 or so millimeters. So I'm going to go down, kind of spin around. Whoa! What happened? Here, let me start that over again. 3D poly. Going to create kind of a center line. I'm going to go down Z. Let's do 60 first and then 67. And then I'm going to go back and just creating some nodes along the way. Enter to exit out. And if I hold down the shift and center scroll button to swivel around, which is what I've been doing this whole time, you can see kind of have the start of a shape that I can use. It was really nice and rigid, which isn't going to do me any good. I'm going to select on that 3D poly, right click, under polyline I have this option to spline fit. I'm going to start with that. Add some curvature to it. And if I click on it, you'll see I have these nodes that I created. And from there I can move them around any which way I want. Kind of getting it to a point that's kind of consistent with my design up here. You could probably spend hours trying to get something that looks good, but for now, let's just say that's good enough for the presentation. What I want to do, oh, and you know what? I caught something again. I want to go back into the X-ray because the moment I create this, it won't look clear, but I'm going to do another circle. I create a smallish one, doesn't have to be terribly big, but within, the extents of my design. I'm going to sweep this guy along my 3D polyline, and you can see we're really starting to work on building an actual realistic looking handlebar. But here's the thing, right now it's a 3D solid, and to really get in and manipulate the design, doing it as a 3D solid is really not going to be of any use to us. What we want to do is work towards creating a nice looking mesh. So I'm going to, again, under Home, Smooth Object, I'm going to select my 3D solid, hit Enter. You'll be prompted, yes, do you want to create a mesh? Sure, I'm going to go ahead and create a mesh, and then there you go. I've converted this to a mesh. It's no longer 3D solid. And this gives me the freedom of going in and really grabbing these different faces and pushing and pulling and scaling, and we can do all kinds of cool stuff. And I'll show you that in a second. But before I do, we do have the option of increasing the number of faces, decreasing them, smoothing it up. You can play around with these different functionalities here. And again, there was like a whole webinar that went into this in greater detail that we've included. So I'm not going to go over this stuff right now, but you do have the option of really getting in and getting this super refined to the point where you can grab these very almost infinitely small faces to modify. But I'm not going to go to that extreme. Let's just keep things the way they are. If I hold down the Control button and I kind of cross over my mesh, you can see that individual faces are highlighted. And from here, I have this little gizmo guy that I can pull any which way I want to really work on refining the design that I want. Kind of keeping that plan view in mind. And I can go down, I can even zoom in, zoom in over here. Sorry if I'm making you guys dizzy. I could bring these guys in, do the same thing over here. Again, I'm holding down the Control key and then selecting the individual faces. bringing it in. So if I start moving around, you see, I've narrowed things down, I've stretched things out there, and, I got a very bulbous looking bottom of my handlebar here. So I'm going to grab all of these guys. Whoops. Grab all these guys. And right now, I have my gizmo set to the move guy. So this is the guy that's going to move me, stretch things out. But I have these different options. I got the rotate gizmo, something that we actually saw before when we were doing the 3D rotate. But I got this other one down here, the scale gizmo. I'm going to select this guy. And this guy's pretty cool. If I have this gizmo active and I have my faces selected, I can grab the different axes and stretch things out or taper things down. I could do some pretty cool things by scaling these faces and having them control how the rest of the design looks. So generally speaking, I think they tend to kind of taper more towards a point. So I'll scale down, and for someone who's not a designer or architect, I don't know, it's looking pretty good. What do you think, Victoria? Looking pretty good? I'm getting the thumbs up. Okay. So say we're satisfied with our design. We got one half of the handlebar assembly here. So I'm going to use the 3D mirror command again. And I'm going to mirror this about the XZ plane. I'm going to select 3 points. I'm going to just take the center of my design here, go down the X axis and then up the Z. Do I want to delete the source object? Nope. And then there you go. Now I have my 2 symmetric handlebars. I'm not quite done yet because these need to connect to a shaft that would eventually lead into the frame. And so I thought I'd come up with this cool thing here. I'm going to take my Autodesk A. I'm just going to move this guy out here. I'm going to design this, I don't know, aggressive looking front end. So I'm going to bring it out front. Oops, I'm still on the scale gizmo. I'm going to go back to the move gizmo. Bring this guy down a bit. 3D rotate. I'm going to grab this guy so I can spin him this way. So let's kind of go up, I don't know, something like that. All right. I'm going to extrude this guy up ever so slightly. Say 5 millimeters. Okay, so I'm looking at this on the front end. Should be good. Now I want to rake this guy all the way down, but it's at a different angle. I'm going to use the extrude face option, but before I do that, I'm going to create a line. All the way down. Oh, there we go. All the way down there. Go back to this extrude face option. I'm going to hold down the control key, select on the face that's closest to my handlebars, hit enter, and then I have the option of defining a height or, in this case, a path. I'm going to type P for path, and I'm going to select the line that I created, and then there you go. Exit out. It raked it all the way through. So I have this nice, pretty cool, aggressive looking front end with the Autodesk logo. There you go. So not too bad. And again, you can go through and you can continue to refine this as much as you want. And then once you're done, if you wanted, you could use the union command to kind of merge or synthesize all of this all into one 3D solid. But for now, I'll just kind of leave it alone. Because next, let's move to the saddle. And I got to say, this was probably the most complicated one to do. And I don't know if you guys have actually really taken a look at a bike saddle before, but it's all kinds of curves and indentations and all kinds of stuff going on. So design-wise, they're fairly complicated, and I'm probably not going to succeed at getting something really stellar for the market. But let's give it a shot. Let's see what we could come up with. So again, as always, starting off with my two very simple designs here. I'm going to, I got the height. It's going to be 50 millimeters, and this is the plan view. So the first thing I'm going to do is I'm going to extrude this guy up 50 millimeters. And just grab this guy, copy him over. I'm going to 3D rotate this guy as well. Whoops, helps if I type it in right. There we go. And just like that frame, I want to really make sure I grab the bottom of this thing before I rotate it. I'm going to grab that one axis of rotation, go down 90 degrees. I'm going to extrude this guy clear through the saddle like that. If I go to the front view, do some QA, QC, make sure everything is looking good. Yep, we got some good overlap going on. I'm going to copy this guy out, move him over here. And like the frame, I'm going to use the intersect. To see where those two 3D solids intersect. So I'm really starting to work towards a nice design here. But I still got some work to do here. And one of the things that I noticed that was pretty consistent with all the saddles that I was looking at was there's this kind of indentation that runs through the center of the bike saddle. So I'm going to try to replicate that. I'm going to create a line along the center of my design here. I'm going to create a small circle. Doesn't have to be exact. Something like that. I'm going to sweep this guy through to create a cylinder. Now in this case, oops, I'll leave it there. In this case, I'm actually going to go over to the conceptual. It'll give me a sense of where these two are intersecting a little bit clearer than the X-ray. So I'm going to move this guy up, 3D rotate, grab that. I'm going to kind of taper it down. I feel like I'm getting closer. Not bad. Okay. I'll live with it. I'm going to go back to the X-ray. Okay. And I'm going to, actually before I do that, I'm going to copy this guy over just so you guys can see the before and after. Subtract. And then there. So you can kind of see how the cylinder I created has now been removed from the top of the design. But still looking kind of rigid. I really need to work on making this a little bit more organic, kind of like you would see on a real bicycle. I'm going to make this into a mesh. Do I want to create a mesh? Yep, sure do. So right off the bat, I'm starting to get something a little bit more organic. And just like the handlebars, I can hold down the Control key and select faces. And the cool thing is if I want things to be symmetric, I can grab the faces on either side. And if I use, any of the gizmos, it's going to reflect and maintain that symmetry of my design. So if I, want to bring this down a little bit, I could do that. Let's see if we can bring these guys in. This might be a little bit more. Yeah, that's going to just slosh things back and forth. So maybe what I can do is I can try using the scale gizmo Oops, something happened. It's not liking that too much. I might want to do these individually, actually. You'll bring it in. Let's bring it in by 6 millimeters. And then I'm going to grab the same face and bring that in 6 millimeters. And oh, you see, I wasn't careful. I grabbed the wrong face. But generally speaking, that's what you would do. I mean, you would grab whatever faces you want and modify them. You can even try playing around with the scale, like if you wanted the front end to be tapered a little bit more, you can go back to the scale gizmo and make that guy narrower or thicker, however you want, until you get something to your liking. I'm going to try something. I'm going to try this on the live webinar because I found this pretty cool trick where if I copied in a little more towards my original design, and the thing about this design that I like is that it has like a nice front end to it that I want to keep, or I want to try to reflect in my final design. I'm going to see if, Victoria, I did this like 3 times and it worked, but watch, because we're doing this live, it's not going to work.
I think it's going to go over well.
Okay.
We also have our first question about what Z is. We're teasing you about Z.
With what? Sorry?
Your Z axis.
Oh, my Z axis? Yeah. Sorry, guys. The Canadian in me is slipping out, eh? Oops. All right. I'm going to copy this guy over. I'm going to try to bring this I want to make sure that there's a decent amount of overlap. And I was actually surprised that using the intersect command in my test worked remarkably well. And it's going to come up with this prompt, and I'm just going to select a smooth 3D solid. Let's see what happens. Oh, is it going to work? Not super well. Here, let me try again. And again, it's because we're doing this live that it's not working. But again, it worked well. Yeah, it is in the final model, but I want to try to see if I can do it. I was amazed. If I can't do it this go around, I'll show you what happened in another. Oh, wow. Not working too good, but let me show you what happened. I'm going to open up the final, saddle final. And you guys will have access to this data set as well. So yeah, so what I was able to do is I kind of overlapped the mesh that I had refined along with something closer to my original design. And when I overlapped them and did the intersect, I thought the final design looked really, really cool. But of course I can't replicate it live. But again, you'll have this data set so you guys can play around with it. But yeah, it was essentially running the solid intersect on the mesh in solid there. So where were we? So here we were. So again, you know, that's pretty much really what I wanted to show you is we got you know, select components of this bicycle designed in AutoCAD. And the thing that's amazing to me is that if we know just a handful of different commands, select functionality in the software, we could easily design and create a 3D model. I mean, with relative ease. And it's also a matter of really just going in there and having you guys play around and test it out and see what works for you, see what doesn't work. And again, I'm not a designer, I'm not an architect. There might be 100 different ways of doing the same thing in CAD, but come up to pretty cool different results. So there you go. So I'm going to pass this back over to Victoria. She's going to wrap things up.
Thanks, Alex. That was a great presentation. Let me take the screen from you here. Just a second. All right, so that was our solid editing tips and tricks, our last webinar of the year. And we're looking forward to seeing you again with more information in 2017. Here are a couple of resources that we wanted to provide you with after this webinar. We've got the links to the Autodesk Knowledge Network, some intro to solid modeling in AutoCAD 2016, some messing with meshes, some previous webinars, solid editing tips and tricks, and some help documents to help get you started using these features on your own. And as always, here are those Knowledge Network links to all the AutoCAD related bits and service packs and updates available on AKN. Okay, so we have a couple of questions. We have a couple minutes for Q&A, I believe, right? Yep. Okay, let's take a look. What is the difference between loft and sweep? Oh, I'm still showing the poll, aren't I? There we go. Okay, now you can see AutoCAD? There we go, excellent. All right, so the difference between loft and sweep is that loft it'll span several different closed polylines or objects and follow that contour, whereas sweep follows a defined path. So if I had contours, like a contour map, that would be a good candidate to use loft on. Whereas sweep would be if you had like a crazy polyline, or the handlebars were a really good example of that. You can follow that path that you created using a 3D polyline. So I hope that answers that question. Let's see. Can you go back to the dataset screen? I have some of this up. I know I took control over the presentation here. This is that final, oh, that's too dark. This is that final bike go with all the parts assembled. We will make the data set available, so we'll upload it to that public box folder. The link is in the chat window as well. Maybe Nauman can pop that in there one more time just to make sure that you have the public webinar link. You should be able to get to that. We'll put it up there later this afternoon or tomorrow so that you'll have it.
Just did, again.
Thank you, Nauman. All right. And then, I don't see any other major questions. We got, yeah, I think we're about good. What do you think, Alex? All right, let's wrap it up for the day then. Thank you, everybody, for joining us, and we hope you enjoy the holiday season, and we'll see you in 2017.